I am Dr. Anup Kumar. Welcome to my YouTube channel Farm Ease. In this video, I am going to explain you what is the area under the curve. Area under the curve is one of the important pharmacokinetic parameter along with the clearance. Area under the curve it represent the different concentration time points which is the drug reached into the systemic circulation. As we have taken here that if the drug is extravascularly administered, such type of the profile has been observed. So how much quantity of the area enclosed by these points is called as the area under the curve. Similarly, for intravascular systems, if the drug is introduced directly into the blood through the IV injections, so such type of the profile has been observed since there is a no absorption phase. So how we can calculate these areas? So these are the different areas and it is being calculated. So the most simple formula is how much is the initial time point and K is the slope. So intercept by the slope is the measurement of AUC in case of the intravascular systems. While in extravascular systems, so AUC is calculated through the integrand of the plasma concentration with respect to time 0 to infinite. So if this much is the area is enclosed, the different intervals 0 to t intervals and t to the rest interval, so it appears look like the same. So we can calculate AUC is basically sum of the two different interval. One interval is this, another interval is this. So it is moving to the infinite points. So one is 0 to time t point and 0 to t2 infinite points. The last time points is calculated. So area under the curve up to infinite is calculated by means, so what is the concentration highest at this point divided by the elimination rate constant. Elimination rate constant is calculated by means of logarithmic concentration versus time and it represents the basically slopes. So there are various other methods by which we can calculate the area under the curve. Is one of the important parameters in which we can find out the dose divided by the clearance, provided one important parameter is the bioavailability factors. So this one is very important parameters for calculating the area under the curve if the clearance is given. So what is the unit of area under the curve? Area under the curve, the unit of concentration is microgram per ml. What is the unit of time? Is it in hours or in a minute? So what is the unit of area under the curve? Microgram per ml into the hour. We can calculate through the volume of distribution is given. Dose, since we know that the clearance is equal to the volume of distribution into the elimination rate constant. How can we calculate the area under the curve? Area under the curve is usually calculated by the three different methods. One method is called as a cut and weigh method, in which we are taking the area of unknown. So this one is area is unknown is calculated and it is weighed. Okay, so this is called as the area is unknown divided by the weight. So we are taking the weight of it, area of the known divided by the weight. So if we are cut a particular portion in triangle and weigh it and we are comparing in this ratio, we can calculate the area. Second important parameter by which we can calculate area under the curve is the trapezoidal method. So trapezoidal method is a mathematical method in which the all the trapezoids, small trapezoids, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 trapezoids are there. So these are calculated. Suppose this one is a C1, T1, C2, T2. So it is being calculated by means of the C1 plus C2 divided by 2 multiplied by T2 minus T1. So it is the area of the trapezoid. So area of trapezoid 1. Similarly, if you want to calculate up to the T11, so we have to all add up to T11s. Second and the third important parameters or method of determination of AUC is a counting method. Usually a graph is being plotted and how much quantity of the small rectangular, small square blocks or rectangular blocks is calculated by means of the planimeters or just simply countings. So these are the few important parameters by which we can calculate the area under the curve. So this one is very important, very basic things. What information we can draw from the AUC? Area under the curve is very important feature, important pharmacokinetic parameter. So what exactly AUC will tell about the pharmacokinetics? AUC will tell you about how much quantity of the drug which is get absorbed into the systemic circulation. As we know that the concentration is moving in the blood and the different time points the concentration is there, so we can say that this much quantity of the drug which is reaching into the systemic circulation. Another important feature of under the curve will tell us about the product performances. Since we know that the drug has been given in the forms of the various doses form, if we are comparing the two different doses form or the same doses form but having the different products, so we generally comparing the AUC of one product versus the AUC of the second product containing the same drug given through the same route. We are just comparing the AUC of product 1 and AUC of the product 2. It will just gives us which product is better. Third important significant aspect of AUC will tell us about the drug is behaving linearly on nonlinear, showing the nonlinear kinetics. If we are increasing the dose from 100 to 200 mg, their corresponding AUC should be increased. Say for example, if the dose size is given through the 100 mg, if we are increasing the dose to 200 mg, so area under the curve should be increased. But if the AUC has not been increased, in that situation we can say the AUC and the dose relationship is not following linearly, and for nonlinear kinetics this is curvilinear, it is slightly changed from, and this slight change will gives us about information about the nonlinear kinetics of the drugs. How can we come to know it? We will come to know through the AUC measurements. So AUC and dose plots is varied. Fourth important aspect which is related to first pass effects. So again the AUC and the dose profile is made, and so a lag phase, a stagnant phase is appeared as we have noted in this graph. So we are taking that if we are increasing the dose, the AUC is being increased. Why? Because the drug is reached into the liver, and the liver enzymes is responsible for the metabolism of the drugs. Hence it will result in the not increasing the AUC corresponding amount of drugs, and hence the AUC become stagnant. Fifth important significance of AUC is when two simultaneous drug has been given through and there is a chances of drug interaction. If there is no drug interaction took place between the two drugs, that the one of the drug is not affecting the metabolism of the another drugs, we will observe the same amount of the dose AUC relationship. So but what happens if the dose quantity or the second drug is affecting the metabolism of the first drugs, either through an enzyme inducer or it as an enzyme inhibitors? In that situations the drug is basically affecting each other. So in case of drug inductions, the AUC's ratio is significantly changed, while AUC ratio is significantly decreased if one of the drug is inhibited. Sixth important aspects of significance of AUC is related to the multiple dosing. Usually the 3 times or the 4 times or 5 times of the drug is being given. So how can we say that the steady state concentration has been reached, or what is the concentration of the drugs when the steady state has been reached and we are giving more dose is added? So in that situation, if the first dose has been given as I've shown here, first dose, second dose, third dose, and fifth and sixth, so what does AUC will tell you? Area of first dose is equal to the area of the sixth dose. In that situation, when the steady state concentration has been reached, we can predict that what is the area of the seventh dose by using this methods. So basically, steady state concentration can be calculated by means of the AUC, depend upon the addition of the areas. I hope you like this video. Interesting. Like, share and subscribe my channel.